This is a talk about the build system for Xamarin.iOS. So the first question is, why should you care? There should be something in the build that's important enough. Well, the best reason for caring are that quicker builds makes you all more productive. That's a good reason to start. It also means that you can get smaller and faster applications. And that's something that's make your application the best application, the more responsive application. And this is all makes your apps awesome. So this is why you should care about the build, about the option of the build, and how you do the things and learn the tools, because it makes you and your application awesome. Now, this is a talk about optimizations. And optimizations, it's true if you're switching options or if you're modifying your source code. It's the same thing. There's a prime directive. When you do optimization, you should time everything often. It's also very important to keep notes. If you're changing things inside your builds, you should know why. Did you do something because it was required to work? Did you do it for performance? Maybe you do it because you were just bug fixing something. You could have been curious about a new option. Those are all reasons why we do change in your options. Now, that's important because at some point, someone, maybe yourself, will ask the question, why did you do that? Why did you use that option? And sometimes the answer is, I don't know. Well, many optimizations were killed and bugs introduced because no one had the answer for that same question. Okay, here we see a graph about building for the simulator and for the device the same application. That's the field service application that you may have heard in other talks or in the training. The graphics illustrate three main points. The first one, the simulator builds are much faster than the device builds. That's likely not a surprise if you have done a lot of development with iOS. It's much faster. It's between 4 times and 25 times faster to use the simulator. The second point is that it's easy when you change your options to slow down your build. That's why timing is useful. And the third point is that the default options that we provide are meant to be safe and fast. They are not optimal for every situation. The only way to get the optimal options are to know your application. And there's only you and maybe a few other people around you that knows your application. So my goal today is to help you by teaching you the options to merge your knowledge with the tools to get the best out of them. Have you ever think about how we build for the iOS simulator? I mean, on one side, you have your IDE, Xamarin Studio, or there's something else called Visual Studio that can do it too. On the other side, you have your iOS simulator. So what's missing? What's in the middle? What do you need to bridge those? Well, you need an add-in that will reside inside your IDE. That will work in concert with the MTouch command line tool. Together, they will package your application, your managed dependencies, your native dependencies, your data, the mono runtime, all together inside a single application bundle. That application bundle will be deployed and executed from the simulator. Now, why did Apple provide a simulator instead of an emulator? Well, it's a design choice that they made. which is different from the design choice that Google made. And it really means one thing. It promotes speed over compatibility. Now, Xamarin embraced the same choice. We want you to have the best and quickest experience to debug your applications. But it's not what makes the simulator faster. What makes the simulator faster is Apple not doing any restriction on the simulator. So you got a less restrictive environment, and that opened the door for a few things. So it enabled us to use the just-in-time compiler on the simulator. That means that part of the build, compiling to native code, is actually done at runtime. And it's not a performance issue because your Mac is much faster than your device. The next thing we do, we try to minimize the number of files that we copy around. There's a lot of files in the build. It turns out that many files, like all the SDK's assemblies, this is the code that Xamarin ships with the product, are not modified. So there's no point in copying the files around. We can create symbolic links to those files and skip that step entirely. Next, whenever possible, we use a shared application launcher so we can reuse it several times. Now, if we did not do this, we will need to create a new one for each build. That's what we need to do for the device. So how can we go from the default times that we have seen to the best times? It turns out the simulator for this sample is quite close to optimal. Still, there are large differences of times. They are mostly due to two things. The first one is that build time, you should avoid optimizing the PNG files. It's good for a release build. It's not useful for a debug build or even on the simulator itself. You can turn it off and you won't see a difference on your simulator. So it's not worth the 13 seconds of the build, which is 2 times all the other steps, just to get that. For deployment, there's one thing you should always do. Keep your simulator running. The simulator itself takes a long time. We're talking about 5 seconds at the minimum to start itself. You only need 2 seconds to start the field service application. That's the difference between the 7 and the 2 seconds. So this is how you get from the default to the best. Now, what should you avoid? Builds are never fast enough, so you don't want to get worse. There are options that will take more time and that you may not need. For the build, you should avoid enabling the linker. The reason is simple. The linker will modify the SDK's assemblies. So if we modify those files, it's not possible to use symbolic links. With no symbolic links, we must copy the files. So that kills an optimization. There's also another optimization with the share launcher. Now, it's not common, but it's possible to share a simulator build across computers or to put it on the web so someone can test an application on the web. Some companies offer a service like that. Now, if you want to do this, the symbolic link won't work because they point elsewhere on your Mac and not inside the application bundle. So you can use the no fast sim option to get an application bundle that will work anywhere for any simulator, any computer, share it on the web. Now, if you use that option, it's going to take a lot more time because you have disabled every optimization that we do. So if you try it, you should remove it afterward, because if you keep it, all your future builds are going to be much slower. Now, to deploy, if 5 seconds were not enough to convince you that to keep your simulator running, well, that was the best time. It can take up to 12 seconds to cold start the simulator. So keep it running. It's worth it. A few tips. Inside your IDE, rebuilds mean clean and build. Cleaning takes time. I have 2 kids, and I'm sure everyone as a kid knows that cleaning takes a lot of time. It also means that you're deleting everything that was built and could be reused. So sometimes it does not seem like it makes a difference, and sometimes it makes a huge difference. Another trick is to avoid file copies. That's because when you build a bundle, you must copy every file inside the bundle. And then you ask the simulator to start, it will copy the bundle inside its sandbox directories. So those are several copies that needs to be made. Now, that's true for assemblies, but it's also true for your own data files. I have an app which has a rather large 80 megabyte database for 250,000 of variable stars. So it's large. If I copy it each time, it takes a lot of time, but because the sandbox is not enforced on the simulator, I can open my database directly from my Mac home directory. That way, I save time on each build, deploy, and I also save space on my SSD, because the simulator, each time you deploy on different iOS version of different iPad or iPhone simulator, you will get different copies. So you save time and space by doing so. Now, to help you measure your time, you can ask mTouch to give you timestamps on every steps it goes through. You can do so by using the dash time option. That's useful if you change your options or just because you're curious, where's my computer spending its time? Let's review the options. So what we talked about was to keep the linker to do nothing. That's a good option. It's a default option. There's not many reasons to change that. You should disable the optimized ping files. It's not worth your time. If you don't have options, additional arguments to mTouch, it's fine. If you have some, it's a good time to review them, to know why you're using them, and to know how much time they cost. And that's where you can put the dash time option to get your timestamps. Building for iOS device is pretty similar to building for the simulator. In fact, the simulator build is a small subset of the device build. What that means is that now the add-in and mTouch have a lot of more to do. The add-in must deal with the identity, the provisioning, the entitlement, the code signing, well, all the security stuff to satisfy the sandbox on the iOS device. mTouch has one big job. It must natively compile all your code to run on that device. And that job means a lot of more steps, a lot of more time. And there's also a lot of more options for all those steps. That's why it's worth your time to see what takes this time and try to optimize it. There's also some more build configuration for device. The debug configuration is the one that you want to keep the fastest possible. You want it to be quick. That's what you will use every day, several times a day. You can do so and you can even affect compatibility. It does not really matter. That's not something you will ship. That's something for you. That's something that should be fast for you. The release build is different. That's where you want to try the option that you plan to ship to your customers. That's where you want to focus on the performance, using slower options like the LLVM optimizing compiler. That's the place to use the optimized ping files. The ad hoc and App Store configuration should be close to the release option. In fact, they should mostly differ by how you will sign the application and how you're going to deploy or share that application. It's important for the device to understand the relationship between the build and deploy. The easy rule is that the deployment time is a function of the application size. So a larger application takes more time to deploy. That's pretty logic. So if we minimize the application size, we minimize the deployment time. That's also pretty logic. So if we minimize the application size, what happened to your build time? What do you think? Does it take more time to build a smaller application? Yeah? Does it take less time to build a smaller application? No one? Well, a few people. Well, you're right. It turns out that removing code from the application takes less time than natively compiling that same code that you won't use. If you have smaller code, smaller object files, then the native linker is going to be faster. You're going to have less symbols to generate, a smaller native executable, which deploy faster. That means that saving space has a double payoff. You save build time and you save deployment time. That's why the Link SDK is default for all device builds. Now, what should you do to get from your default to the best times on a device build? For the build, again, for your debug builds, you can still avoid optimizing the ping files. It's not a performance issue. It does not give you anything. It's not a release. Save those 13 seconds. They're for you. There's two more things you should consider. The linker is enabled, but it's limited to the SDK assemblies, the code that Xamarin ships with the product. Now, you can go one step further, and you can optimize every assembly, including your code. If there's more code, more savings, less time. There's another thing you may want to try. It's a little bit tricky. What takes a lot of time if you have native code, extra native libraries, bindings inside your application, is generating the symbols. That's running Apple DSymUtil tool on your application. It can be very slow. We have seen a case where it took 70 times to build symbols compared to all the other build steps. We're talking about an hour, more than an hour, to build symbols for a build that did not took 1 minute. Now, before turning it off, it's important to time, and it's important to know that the symbols are important. Without the symbols, all your crash report won't have any useful information inside them. So this is not something you want to try on any build that you're going to share with someone else. But if you're not debugging a crasher, you can try to disable this option on your day-to-day build. That's going to get you faster. In this case, there's about 8 seconds. There's not much native code. 8 seconds to save by not generating the symbols. There's a few options that takes a lot of time, but don't give you much back in return. This includes the fat binaries. Fat binaries are great if you want to create a performant application for release. That means that your application is compiled for every CPU you choose. So it's very optimized build for each of them. Now, if you're debugging, you're only executing and debugging one CPU architecture at a time. It's not worth building them. Now, if you build them, it almost doubles the time to build and deploy your application. The other option you should avoid is to disable the linker. Because if you disable the linker, you will create huge application. Huge application, huge build time, huge deploy time. So you're not saving time by disabling the linker, even if the linker takes time itself. That's also true for every option that prevents reducing the size of your applications. Those options are there for debugging or for other purposes. They are not there to optimize your build time. It's even more important for not to disable IL on release build, the no-strip option. If you do so, you're shipping your IL code with your project, your application. That means it's far more easier to reverse engineering your code. Think of it that as the AUT compiler is the ultimate obfuscator for your code. And it's free built-in. It's much, much, much harder to read and interpret what ARM assembly code than IL code. So that's a feature, and disabling it does not give you any build advantage. Okay, some extra tips again. Avoid using rebuild. Every native object code that we generate is cache. If you use rebuild, we remove the cache. So there's time to save by using build, even more on your device builds. Now, the iOS on device enforced the full sandbox over the file system. But it's still possible not to deploy large assets on every build. My 80 megabyte database, for example, I use the UI file sharing enable in the info playlist, and I use iTunes to upload to the document directory of my application the database. I do this once, and then I deploy my application by itself. It means I can build and deploy my application in 5 seconds instead of 20 seconds. When you take months inside the same application, which has a large data set, large assets, there's a lot of time to be saved by not deploying them each time. Again, there's a lot more steps, there's a lot more options when you're doing a build on the device, so asking for timestamps is even more useful. That will quickly tell you if generating the dwarf debugging symbols is worth your time or not. Are you saving 2 seconds or 2 minutes? You will see it right away. Let's go over the options so everyone knows where they are. Link SDK is good. Link all will be even better. For debug, not release, but debug builds, you can disable the optimized ping files. The additional arguments, that's where you could put the -dsim equal false. And again, you can ask for the timestamps. Now, if you disable the symbols, remember, if you hit a crasher, if you plan to share that build, you should remove it. For the advanced options, well, make sure you're only building for debug for a single CPU architecture. You do not want fat binaries. Also, make sure that the LLVM compiler is not enabled on debug builds. It's not supported. It will work. It will give you a warning at build time, but you won't get the debugger working with it, and it will only be slower. So it's not useful. So far, we talked about the option and how they affect your build time. Now, the same options also affect the size of the executable, and it also affects the speed of your executables. That's a release build for the field service application. So it's kind of the same graphics, but not for debugging, for release. Here we see that disabling linking takes a lot of time. It's 3 to 4 times longer to build. But it also generates a huge application that's nearly 50 megabytes. Where does it come from? Well, it's your native executable that is being much bigger. Maybe you don't know, but since last month, Apple has a new restriction and will reject any application that has an application executable size over 60 megabytes. So just by that sample, we're getting close to that limit. Now, the default is Link SDK. It's 33 seconds and less than 12 megabytes. That's much better. But as we have seen, if you use link all to link everything, well, you're still saving space. Now, that sometimes does not seem logical because the logic will say, well, if I wrote all that code for my application, then the linker has nothing to remove from it. What can it remove? Well, when you start sharing code between your application or you start using components, third-party components, well, you start using code that is not your own, and you're unlikely to use everything inside it. For example, field service use Xamarin Mobile. That's a great library. It covers a lot of different API, cross-platform APIs. It will cover accessing your camera, your contacts, and all the stuff that is common between mobile platforms. But it's not common for a single application to use all those services. Now, if you don't link that assemblies, what does it mean? It means that all the code for all those services ends up inside your application. That's why we can save more than half a megabyte of code just by switching to link all. Also, since it's smaller, well, it builds faster and it deploys faster. We save 3 seconds. That's not much, but it's a small project. It's still 10% gain in build time just by switching to this option. Now, there's a catch. If you use link all on the field service sample, well, it will crash. It will throw an exception after the logon screen. Why does such things happen? Well, it turns out that field service use SQLite.net for its database access, and it's a great library, and it's a very smart library. And it uses reflection on your types to map your types with the database tables. Well, static analysis and reflection don't work together. Static analysis cannot deal with the dynamic of the reflection. It needs help. The way to help it is to tell him what to preserve. So you can instruct the tools to keep things inside your application. In that case, for SQLite.net, you want to preserve the 10 types that are used for database tables. And it means adding one line. What we show here is how you can do it and keep the code compatible across iOS, Android, and Windows Phone. But the key point is the preserve attribute. If you put those 10 attributes, then you get all the benefits of link all. Now, in some case, you don't have the source code, or the source code is generated by a tool and you don't want to change it. Well, you can still link everything in that case. You need to create an XML file that will describe all the types or the members that need to be preserved, and to give it with the --XML equal your file name, and then the tool will read this process it exactly like you were using attributes. The end result will be identical. You will get the same size optimization. Just the code you need to run. Now, if you plan to move a large application, existing application, and you want to start using link call, you may say, well, it's going to take a bit of time to figure out everything that I need to preserve. Well, there's two ways that you can use, two tricks that you can use to partially link your application. The first one will be to link everything and to skip some assemblies. Like in this case, the field service iOS is where the database table, the types are defined. You will lose part of the size optimization, but it's very easy to do and does not require you to have access to the source code. You can just use the additional link skip option. The other way to do it is to use the new linker safe attribute. When you use linker safe inside one of your assemblies, you're effectively telling the system that this assembly is safe to link, and we will process it exactly like we will process Xamarin-owned SDK's assemblies, which means it will be linked even if you use the link SDK option. But it requires you to have the source code to make such change. Who's using Objective-C bindings? Quite a few people. Well, Objective-C bindings are great candidates to be optimized and linked. Using the linker safe attribute on Cocos 2D saves more than 400 kilobytes of code on the jumpy sample. That's just by adding one line on your bindings. That's because it's uncommon for an application to use everything inside a native assembly. If you don't use everything, then why should you build and deploy all the bindings for it? You're not using the native code. You don't need the bindings for those part of the code. It also saves a lot of export attributes, which means you get faster registration. Registering the types is pretty fast, but if you have to register thousands of them, it will still take more time than if you only have to register 100 of them. There's also a new option which is called Smart Link. That's in the very latest release of Xamarin.iOS. It does about the same as what we talk about, but it does it on the native side, not on the managed side. So you can use Smart Link with your link with attribute and specify an option to use the new static registrar. When doing so, you help the native linker to eliminate native code from the library you're linking against. So samples like Dropbox Sync will drop by more than 300 kilobytes when using Smart Link. Other samples have reduction from 250 to 400 kilobytes of code. Now, just like the managed code, there are sometimes some libraries are doing dynamic lookup of symbols. Such libraries won't work with Smart Link. But otherwise, it's still a very easy thing to try. You got one line of code to change or to add with your link with attribute and use this new static registrar option. Now, to continue on bindings, bindings can be simple to create. You see the first two lines? That's a simple binding, no return value, no parameters. That's how you define it in C# to map with the Objective-C code. What you see on the rest of the slide is the code we generate to cover every possible case. Now, the linker is pretty smart with bindings, and it runs an optimizer on that code because it knows that there's too many conditions in there that you won't find in real life. You need all that code because the same code must be run on the simulator, on device, for debug, for release, and all that stuff. So The optimizer can remove unused or unrequired attributes like compiler generated. It's not needed at runtime, so we can remove it. For a release build, by default, we will remove the UI thread check. So we remove a call. So if that method is called inside a loop, that has a very high cost to do much more calls. Now, the next one is pretty interesting. It turns out that when we do the static analysis, it must be global on all the code of your application. And since Apple does not allow you to download new code or generate code at runtime, it means that we know if that code is going to be subclass or not. Since we know all those things, we can already predict what its direct binding value will be. So we can remove all a branch to simplify this binding. So that binding finally is just one line of code. It's called the messaging direct to the selector. Here's another case. Sometimes with the Objective-C runtime library, knowing if you're targeting a device or a simulator is different. You must use different APIs. That's true for structures and floating point values. We don't expose this to developers, but for people doing bindings, it's pretty important. So if we use the same previous optimization, and we already know if we're deploying to a device or the simulator, we can simplify this a lot. So the outer branch is removed because we know that that code won't be subclass, and the inner branch can be simplified because we know we're running on a device. 2 branch remove, less branch, faster code. A last example. We can also optimize the binding based on the garbage collector you select and the option that it's using. So along with the previous optimization, if you're using BOEM or SGen by default, we can remove the isNewRefCount enable check. One less call. Now, if you use SGen with the newRefCount option, we can also remove the backing field. So we're not just reducing the code, we're reducing the size of that type, which means that at runtime, this type and all its subclass will require less memory. So the more objects of those types you create, the less memory it requires. There's a lot of other options that are less easy to demonstrate. But the important thing is that if you don't link your bindings, you're not getting any of those optimizations. So every application is unique. Everything you wrote, everything I wrote. With your knowledge and what we covered today, you should be able to get quicker builds, smaller application, and faster application. And all that stuff should be delightful, both for yourself and for your customers. Any questions?
What's the downside? What's the downside?
Downside of a specific? No, it's not all good. There are parts where it's always to measure what you get out of it. I mean, sometimes it takes more time and it's worth it. Sometimes it's just not worth it. The downside for all of this, I will say, is that you need to time your builds, and you need to do this often. I mean, if you change things, you should redo it. It's not something that will stay static over time. Something like, yes, if you want to optimize and you say, my bindings, I put a linker safe attributes, well, it's forever again after that. But there are other options and other stuff that you should measure. So it's a recurring cost to make sure that you're saving time. It's worth it, but you must do it. Yeah. The question is, if we use Link SDK, do we copy the assemblies or not? Okay. For the device, we always copy because it must end up inside the device. For the simulator, when we use Link SDK, we must copy the SDK assemblies because the linker will process them and will reduce them. But if you don't use the linker, we can use symbolic links. But that's only happen on the simulator when you don't use a linker.
So if your solution is broken into multiple components, so that produces multiple systems, does that, the definition of a smaller app, the collection of these symbols or the compile the main application?
So the question is, if there's multiple projects, what's the definition of the application? Is it all the project or each one of the projects? The option screen I've shown is only available on the solution. It's not on the solution, but it's only on your main project. All those rules, the linker runs on the main project and all the dependencies of that project. So you do not need really to take much care when you develop a single assembly, unless you want to use the linker safe attribute or use some preserve attribute to be sure that you can apply link all. All those decisions are made at the application level, so your EXE.
So my execution, should that imply, if you've got other projects in the solution to the reference file, you're not going to small execute because
So the question is, if I have an executable and several libraries, do I end up with a smaller executable because of the reference? Okay. For the device, what happens is that everything is compiled inside a single, and that's Apple rules, it's not something that is Xamarin specific. Everything is compiled into a single native executable, including your native libraries that you're linking against. We do still ship the assemblies, and on release, we remove the IL from them because the metadata still exists, and we still need to read them for reflection and all that stuff. So we still ship the assemblies, but we have removed what we don't need from them, and we remove the IL on release builds.
So the 60 megabyte limit from Apple, will that include the other assemblies from the other projects?
The 60 megabyte rules from Apple is on the main native executable. Only the code that you can run and execute. All the other assemblies in Xamarin.iOS are just data at that point.
So is it the case that on both iOS and Android that you've basically got two scenarios? You've got the development scenario on the simulator, emulator, where it doesn't have to do a link step, it's just JIT, and it's basically multiple assemblies going into that. But then on device, you've basically got a single entity, single package, monolithic linked final piece on the phone, on the device. Is that kind of?
Yeah, the question was if the build for the simulator was pretty different than the build for the device, and the answer is yes. The simulator is a subset that because we use the JIT on one side and the AOT compiler on the other side, they are different. That's why I was saying that the choice of both Apple and ourselves is to promote the speed over the compatibility.
But I guess the other thing I was asking is that split and model the same on iOS and Android?
So the question is the simulator and the device, how we build for each of them, is it the same thing between iOS and Android? And the answer is no, because Android does not do AOT compilation. They still use the JIT everywhere. So they have different challenge than we have for iOS. So doing the JIT on the device opens new possibilities that we don't have. But Sometimes we can do further optimization because we know that there's no more code that will be added at runtime.
Is there a reason or a compelling case to be made for doing ahead of time on Android as well? Is that something that's a possibility?
The question is, will it be worth to do AOT on Android? I don't work on an Android team, so I'm not sure exactly how much. I would think so because some people are using AOT on either on Windows with .NET, Microsoft.NET, or with Mono. So yes, there's certainly a case that it will help. I'm not sure how much it will help and exactly what the cost will be in build time, if it will be really a very useful option. But it's a very good question.
I think you might run into trouble. There's such a variety of manufacturers.
We're doing analysis on bindings. So you actually taking the native library and reducing, eliminating code where possible. You're doing static analysis, just like you do in Robo. Is that what's happening? Is that what you were saying?
Okay, the question was if we were doing an analysis on the binding with the native code or just the managed code. Okay, so there's two steps. The linker only, the managed linker, the one I talked the most about, is only working on managed code. So it will remove the code you don't need from the managed code, so the bindings, and will reduce them in the export. The new smart link option that we talk about is working on the native code. Okay, but it's still the native linker that does its job. We're just easing the way it can be. But there's way they work together, because if you don't have reference, because you run the linker on the managed code, you don't have reference to some C structures or Objective-C code, all that thing. Since you don't have this, it's easier for the native linker to remove that from the static library as well. So they play together. Without knowing each other, they still play together. So the question is, could we use the JIT on the iPhone? I'm not sure it's possible, and because when you run inside the debugger, when we debug on the iPhone device, there are some restrictions that are left by Apple, but they don't lift enough restriction to make it easy to JIT. So maybe we could act something to be able to do it, but Apple could turn it off on the next version because they really don't want code to be generated and executed on the device.